Okay, folks, sorry about that. I had a video issue. We'll pick up right where we left off. Obtaining critical values for a one mean z-test. Determine the critical values for a one mean z-test at the 5% significance level. Alpha equals 0.05 if the test is two-tailed, left-tailed, or right-tailed. Well, let's think about the two-tailed test first. And remember, with a two-tailed test, we have this right here is a rejection region, and this right here is a rejection region, and they are equal to one another. So if this is 0.95 and these two rejection regions are alpha, which is 0.05, so what are each rejection region, since it's symmetrical, normally distributed, equal to one another? That's 0.025. Okay, so each of these is 0.025. Now, when we get ready to solve this, we got to just solve for this area here and this area here. Well, to get our critical value. So, to get this area to the right, that's z sub 0.025. Z sub alpha of 0.025 would give us this area here. Now remember, in order to find this area, we have to go to table 2 in the back, like we did a moment ago. Search for the area and find the z-score. But remember, before you do that, we have to subtract 0.025 from 1 and get 0.975, because remember that table 2 in the back is area to the left. This means area to the right. Okay, so you have to subtract, remember. Now look up this area in table 2 and you'll have your answer to this problem, which should be 1.96. We did this in chapter 6. If you want to go back and look at your chapter 6 notes, videos, etc., to review yourself. Now that just gave us this area right here. Okay, that just gave us this one. Okay, that's the z-score. That's the critical value right here for this rejection region. The critical value is 1.96. Well, what about for this rejection region over here? What is this critical value going to be? Well, we have to find 0.025 to the left. Now, that's not going to be very difficult because we don't even have to do one of these z sub alphas. We just need to find 0.025 to the left. What is the z-score for that area? 0.025 to the left. Now, remember, the table reads to the left. So you shouldn't have to do anything but just look it up in the table, since the table already reads to the left. So I'm going to turn back there with you, and if you turn to your appendix in your book, and you look at table 2, and look for 0.025, you should get 0.025. You should get negative 1.6 for that z-score. Well, look, that was positive 1.96, negative 1.96 for that critical value. So there are two critical values there that we would have to test data against if we were trying to figure out rejection versus not rejecting. Okay? So here's what we generally say. For a two-tailed test, if we have a two-tailed test where we're trying to find the critical value, like we did here, okay? We generally say that this critical value is negative z sub alpha divided by 2, and this critical value is z sub alpha divided by 2, positive z sub alpha divided by 2. Now that's for a two-tailed test. That's for a two-tailed test. For a left-tailed test, think about what we have here. For a left-tailed test, so we want to find the area of this region here, and this region is still 0.05, but it's It's a left tail, so it's all to the left. So the rejection region would be to the left. So just go to your table 2, look up 0.05 since the table reads to the left, 0.05 to the left, and you're going to get negative 1.645. We solved that just a moment ago. Now, here's what we typically say about left-tailed test. This is what we typically say about left-tailed test. The answer is negative z sub alpha for a left-tailed test. So look up negative z sub alpha, and that will give you your left-tail answer. Okay? And for a right-tailed test, alright, so we're looking for the area to the right that's 0.05. So the table 2 in the back reads to the left. So this is the same thing as z sub 0.05. So what do we have to do? We have to subtract 0.05 from 1 and get 0.95. Then take your 0.95, and if we go back to our table, okay, table 2, get used to flipping there. 0.95. If you look for 0.95, you are going to have 2 that are split again. You're going to have 0.9. You're going to have 0.9495. And you're going to have 0.9505. And so you have z-scores of 1.64 and 1.65. So you have to take the average again in order to get the answer to this problem. And so the average would be 1.645. Now all this is chapter 6 material. So this right here would be 1.645 for that critical value. Now all these are z-scores, but they're all critical values. Critical value. 2 critical values up here. Now, what's our in general? Here's what we say about a right-tailed test. In general, a right-tailed test, we say we find it just by figuring out what z sub alpha is. For a right-tailed test, we just figure it out by finding out what z sub alpha is. Now the summary of that, of this right here, these in general summaries of how to find these when it's looking for two-tailed, left-tailed, and right-tailed, these in general summaries, there's a nicer drawing than what I can draw on this pad on page 353 in your book. You can turn and look at that. But this is just using what you already know. So basically, the critical value is going to be that z-score that separates rejection region from non-rejection region, okay? That's what we're doing here, rejection region from non-rejection region. The shaded areas are the rejection region. The unshaded areas are the non-rejection regions, okay? Do not reject. All right, so as far as steps in the critical value approach, here's all of our steps. Step 1, state the null and alternative. Step 2, decide on the significance level. Compute the value of the test statistic, our z-score there. When I say test statistic, I labeled this when we went over this a second ago. But remember, our test statistic is this right here. Okay? This is the test statistic. Determine the critical values. Remember, Find your z-scores like we just got finished doing, using your significance level so that you can find the critical values. Then test your data and let me define this a little better for this particular problem. Okay, and then take your data, plug it in your test statistic, and figure out the z-score. And based on your alternative hypothesis, see if it's less than, greater than, or so on. Okay, if the value of the test statistic falls in the rejection region, reject the null. Otherwise, do not reject the null, and then interpret the result. Okay, these are the steps in the critical value approach. It's kind of complicated to explain to you over a video. I understand that. This is one of those sections that you really need to read as well as watch the video. So please do that, and if you have any questions, feel free to ask your instructor. Have a great day.